I've done quite a few videos on TP-Link's Omada network solution on this channel, but honestly, it's been a while since my last one, and that changes today. What I have here are some of the newest gear from the Omada lineup equipped with 10 gig, 2.5 gig PoE, and Wi-Fi 7. Along with this hardware, I also want to take a look at the software to see how it's changed, if at all, since the last time I checked it out. Is Omada still going to be the best bang for your buck SDN around? Has their software added enough features to be competitive in the small business and home lab market? Well, how about you watch the video and we'll talk about it. But before we jump into this, let me just get this out of the way first. Yes, I also do Unify content and run Unify Network in my house. No, I'm not sponsored by either them or TP-Link, so this is completely unbiased. With that said, this video will be focused on Omada. However, I have inside information that the next Home Lab Battles video will put both of these titans of networking up against each other, so stay tuned for that. Okay, so prior to this, I've kind of seen Omada as this budget entry to a proper all-in-one network setup. You could probably tell since I've only really covered what I call the Omada short stack, which is basically an entry-level hardware setup. However, over the last few years, they've grown their hardware lineup to include some much more capable gear. I have 4 of those right here. The first being their ER707M2, which is essentially their upper mid-tier router, not quite their highest end one. It's got 2 2.5 gig ports, 4 1 gig ports, and a 1 gig SFP port, and a USB port. One of the 2.5 gig ports is a dedicated WAN port, while the others are WAN-LAN combo meals. Yeah, you apparently have 6 WAN ports on this thing. That's nuts. You can even use the USB port as a WAN if you have a cellular hotspot. Diving into the specs, you'll see it has support for things like VPNs, load balancing, LDAP, policy routing, all that kinds of stuff. There's a link in the description to everything, so go read up on it if you want to see the full list. So I mean, yeah, for a router slash firewall, this thing is pretty capable. There are a few things that kind of jumped out to me though. One is the lack of PoE. It's not really a negative since most people building out a network will have a dedicated PoE switch for their access points and cameras, but if you're building out a super small network with like a single access point, then having PoE ports on your router is a pretty nice touch. I don't know that it's really enough to deduct a whole RAID owl point, just something I wanted to bring up. Another thing that jumped out to me was when reading the specs, the throughput of this device with IPS routing on is listed at 200 megabit per second. That has to be wrong, right? For those of you that don't know, IPS is Intrusion Prevention System, which basically scans traffic to make sure nothing fishy is coming in. I wanted to test this, so I turned it on, and you'll see what I figured out later. At a price of $200, I think it's priced pretty fairly. I would have liked to see a controller built in though, instead of having to buy one separately, but again, for the price point, I think that's fair. Next up is the SG3218XP M2, an 18-port PoE switch. It's got 8 2.5 gig PoE plus ports, 8 non-PoE 2.5 gig ports, along with 2 10 gig SFP plus ports. This is probably as close as you're going to get to the optimal home lab switch in my opinion. Note that I didn't say perfect. I said optimal. You get 8 PoE plus ports with 240 watts of power budget, you get 16 whole 2.5 gig ports, and you get 2 10 gig ports. With 2.5 getting more common on the client side of things lately, along with Wi-Fi evolving past 1 gig speeds, it's nice having all of the ports here being 2.5 gig. Then our 2 10 gig ports will allow us to connect some 10 gig clients if we have any, but more importantly, this gives us a 10 gig connection to a downstream switch, which we're going to see in a second. In terms of switching throughput, we get 120 gigabit per second, which is plenty. Don't even pretend like you're going to be pushing more than 120 gig through your network at one time. Also, this is an L2 plus switch, which you probably guessed is a nice middle ground between layer 2 and layer 3. Honestly, it looks like it's pretty much an L3 switch, but here's the list of features. Yeah, it'll even act as a DHCP server, which we will see in a bit. I will say that the fan on here is audible, definitely not loud by any stretch of the imagination, but you can certainly hear it, which is to be expected with 240 watts worth of PoE power. At a price of $500, this is the most expensive hardware we're going to look at today, but again, I think that's a fair price for what you get. I'm not saying it's cheap, I'm saying it's fair. Next up, we have another switch, the TLSX308F, which is an 8-port 10 gig switch. All 8 of the ports are SFP+, so depending on what you have in your lab, that may be a good or bad thing. There honestly isn't much to say about this thing. It's got the same L2+ features as the last switch. It's got 8 10 gig ports and a switching throughput of 160 gigabytes per second. As someone with quite a few 10 gig devices in their network, this is the switch I've been waiting for from Omada. I've always run into the problem where I need more 10 gig ports than most switches have, but not enough to drop like thousands of dollars on an enterprise level 10 gig switch. This solves that, and the best part is the price. It's only $240. I think that is an awesome price. 8 10 gig ports on an L2+ managed switch for under $250 is awesome. Personally, I wish it was RJ45 since most of my 10 gig clients are RJ45, but it's kind of a me problem. The last thing I have here is the EAP772, a Wi-Fi 7 access point. I've kind of moved away from covering Wi-Fi stuff on this channel mainly because there's just too many variables that can affect performance. Things like Wi-Fi congestion, interference, client drivers, MIMO configuration, what your house is built out of. It's just a pain in the ass. I can, however, give you an objective view on it. This is their lowest tier in their Wi-Fi 7 lineup, which gives you a tri-band configuration with a total throughput of 11 gigabit per second. It's got a 2x2 configuration across all bands and of course the full fat 320 megahertz channel on the 6 gigahertz network for those juicy Wi-Fi 7 speeds. Something important to note is that Omada does support MLO, which may be the most important feature of Wi-Fi 7. Basically, it allows you to combine all the 2.4, 5, and 6 gigahertz bands together instead of your client having to choose a single one to operate on. Here are my speeds from my Wi-Fi 7 enabled Snapdragon Surface laptop from basically 3 feet away. This access point does have a 2.5 gig uplink, which may have you wondering why they wouldn't include a 10 gig one if the max throughput is 11 gig. Well, at the price of $170, you get 2.5 gig. If you really think you need a 10 gig uplink, then snag one of their fancier models. But yeah, common theme here. Solid features, solid performance, solid price. With all that said, I think the hardware is great. Omada has definitely stepped their game up to offer some more premium options and at a great price. However, for you to have a good network setup, both your hardware and software has to be good. So let's dive into the Omada UI to see what we're working with. All right, so this is going to be a huge deep dive into the Omada UI. It's probably its own video, but I am going to cover the main things. So here we are. Let's log in. And the first thing you'll notice when using any SDN is their UI for the most part, their dashboard. And I will say Omada, it's fine. It's not the fastest. It's not the most intuitive. It's not the sexiest, but it's fine. So here's your main overview with all your sites. We're going to go into our specific home new site, which is all my new hardware into one site. And you'll just see it's not super fast to load. It's not terrible, but I do like how customizable their dashboard is. So you can see here that I have some little widgets on my dashboard, and that is completely up to you which ones you want to use. You can click this little cog over here and it'll give you a bunch of widgets to choose from that you can kind of just drop on your home page. And you can also separate this into tabs. So they do give you a network and a clients one by default, but you can also add new ones or modify these, which is really nice. I think this is the most customizable dashboard I've seen on any SDN. I do wish you could see specific client activity, not just like how much bandwidth they're using, but pretty much like what traffic is going through there, what websites those devices are going to. I don't think you can do that on here. I may be wrong, but yeah, I wish they had that. But there's 3 main things that I think are important when it comes to any SDN, and that's network/VLAN creation, firewall rules, and VPN. So let's kind of take a look at all those. In terms of network creation, I do like how Omada has implemented it. So you go over here to wired networks, LAN, and this is where you have all of your networks you've created. So they'll give you one by default. That's just your main network. Then you can create others. You see I have 2 here, slightly different. One is a guest interface. that has the VLAN tag of 69. Then I have a test V, which is a virtual VLAN with the tag of 20. So you can see in here, the interfaces have their own subnet. So they're essentially their own entire network with their own DHCP server with a specified DHCP range. A VLAN is just saying, hey, I know this VLAN exists. We can use it elsewhere. We'll see that in a bit. So yeah, I mean, it's easy to create. If we go into our guest one, you can see you can specify the type, which physical ports you want it to use, VLAN tag if you want that, the subnet, the range, all that good stuff. Super simple. I actually do like this. Now, if we go over to internet, that'll show our WANs. Like I mentioned before, this thing can handle a crap ton of WANs. So you could see we only have two physical ports, but you can set a whole bunch, including the USB port. Then down here you have your load balancing, and that'll probably be another video. I covered it in one of my earlier Omada videos. It's essentially the same. So in terms of networks and network creation, I like it. The next thing is firewall rules. So that is going to be under network security. Then you would think you'd go into firewall, but that is just like generic firewall settings. A lot of these I don't even know what they do, to be honest. That's going to be in ACL. And you'll have up here, you'll have gateway ACL, switch ACL, and EAP ACL. All different functionalities, but when you're talking about inner VLAN communications, for the most part, you'll be doing gateway ACLs. So you can see up here, I have one that's called block guest. Now let's take a look at this rule. And I do like how Omada implements firewall rules or ACLs on here. It's extremely intuitive. So you give it a name, if you want it enabled, the direction. So this is going to be LAN to LAN. If it's a deny or permit, any protocols, for the most part, I just select all. Then down here, you can select your source and destination. So you can say, do you want this to be a network to network? And obviously we do. You'll see there's different options when we get into switch ACLs and the access point ACLs, but this is network to network or inter VLAN communications. So we're going to say we don't want our guest VLAN to communicate with the default. And the reason we have to create this is because by default in Omada, any new VLAN can access whatever unless there's a specified rule already in place, which I don't particularly like. I think by default it should be off, like no access to everything, but that's the choice they made and that's what we have to deal with. So we're creating one that says guest should not be able to reach the default network. So let's take a look at that in action. So here you can see on the left, this is a device in my main LAN with that 0.1/24 subnet. And on the right, you can see this is part of our guest VLAN with the 69.1.24 subnet. So based on that rule, I should not be able to ping back into our main network. And we can't. Good. But that's only one way. So from my main network, I should be able to ping into our guest network, which I can because that's a one-way rule. So you can also do ACLs at the access point level under this EAP ACL. I have one here, it's not doing anything, but just to show you, it's pretty interesting. You can go in here and it's pretty standard from what we saw before. You have network to network ACLs, but you can also do SSID to network ACLs. So you can pick a specific SSID and block all wireless devices using that SSID to a specific network or networks. Interesting. I don't know why or when you'd use that, but maybe some of you are, and the feature's there, so neat. One thing I did want to cover is a cool feature of those switches and how I did mention before that they're L2 plus switches, or essentially like L3 switches, meaning they can do inter VLAN traffic directly on the device and act as a DHCP server themselves. So here's where I'll show you why I set up this test VLAN right here. So let's go into devices and I'll click on my 10 gigabit switch here. And note that this is where both of my devices that I've been testing on are plugged in at. So if I go here into config, scroll down, you'll see this VLAN interface section. If you click on that, you'll see all of our interfaces as well as those virtual VLANs. So what we want to do is go into that virtual VLAN, enable it, and then click edit. From here, you'll see a lot of stuff, but the main two things we want to look at are the IP address mode and the DHCP mode. So the IP address mode, we're going to set it to static, and we're going to set that to the IP address of the subnet that we're going to set. So in DHCP mode, usually this would be none, and all your DHCP stuff would be handled by your router or gateway. But since we want this server to act as its own DHCP server and essentially act as its own router for this VLAN, we'll set this to DHCP server. And from here, we can specify the range and the DNS and the gateway and all that good stuff. So once we apply this, this means that for that VLAN interface, and only for that one, this acts as a router. And we'll see why that's important really quickly. So let's go back into our two 10 gig devices. Now note that both of these are connected to the same 10 gig switch on different ports, but one is in our main network and the other right now is in our guest network. So not quite on that test one yet. I want to show you something first. So let's go ahead and do an iPerf test. So we aren't getting a full 10 gig, even though we're connected to the same switch. Why is that? Well, since this is inter-VLAN communication, this has to be done by the router. And since the routing is done for these interfaces back on the gateway, it has to traverse all the way up that gateway. And the fastest connection we have is a 2.5 gig connection from the router to our switch. And then from that switch, we do have a 10 gig to our main 10 gig switch. So you're only as fast as the slowest point. Since it has to traverse all the way up, we are only getting 2.5 gig. Now, one thing I mentioned that I did want to test here. Is the IDS IPS speed. So they did show that it was fairly slow in the documentation. So I'm going to turn this on and see what our speeds are. So we're going to do straight up IDS with IPS, apply. And with that inter-VLAN communication, we should see what kind of speeds we get now running the same exact test. That is very slow. Okay, I am shocked. So we went from a full 2.5 gig. We probably could get more with a faster connection to our router, but we only have 2.5 on the router. So theoretically, that's the fastest we can get. But now we're down to 43 megabit. With IDS IPS turned on. So that's not very good. With that much of a handicap, I would just straight up turn it off, which is what I'm going to do. Okay, so to show the significance of doing routing at the switching level for that test VLAN, I went ahead and put that device on the right here on that test VLAN, so you can see we're part of that. And now if I try to ping back to my main server, which is on the same switch, on a separate VLAN, now we are getting a full fat, pretty much near 10 gig connection. So it's pretty important if you want to do layer 3 routing at the switch level, you can do it. And it's not too much of a pain to set up. So the last thing I really wanted to touch on was VPN. So if you go into settings, VPN, you have VPN and you have WireGuard, which is interesting because WireGuard's separate for some reason. And I think it's this way because WireGuard, I don't think it's fully finished here because the configuration just doesn't really work. So you can set up a WireGuard server, I guess, and then when you go into peers, you can set up one, but there's no way to kind of like export the information or the config. I guess you could do it manually, but every single SDN I've set up that does WireGuard is way more intuitive than this. You set up the server, add a peer or client, and then you can just export the configuration to import into your client that you want to connect with. This doesn't do that. It's very not intuitive at all, which is strange because if you go into their regular VPN stuff, it's a lot better. So in here, you can see I've set up a VPN and I've done this with OpenVPN. So if we take a look at that, When you create one, it'll ask you if you want to do site to site. So this is if you have multiple Omada sites at different locations, you could do that here. But if it's just a standard client to site VPN, select this, and then it'll ask you for a VPN type. I typically use OpenVPN. So then you say, is this a VPN server you're setting up or a VPN client? Now we're going to be setting up a VPN server, obviously, so that we can connect back in. Then all this stuff, you can set passwords, blah, 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 authentication mode, which WAN you want it to work off of, which networks you want it to be able to access. And then, yeah, if you want specific DNS servers, you can set them here. Then over here, you have VPN users. So you can go ahead and create your VPN user, and then you can select the server you want to give it access to. And I've selected the one that I created, obviously, and I've given it a password. And now the cool thing is with this VPN server, I have this little export. So I can click that button and boom, it gives me my open VPN file that I can just import into my client and connect back with my VPN user. Super simple, super easy to do. Their VPN stuff is solid if you're using OpenVPN. If you're using WireGuard, I'm hoping with some updates they make this better, but we'll see. We'll monitor that. Now, I know I didn't cover everything there is with Omada, honestly, not even close. That's probably deserving of its own video. But overall, I think the software has definitely gotten better, but I also don't think it's reached its potential. I'd love to see them improve the overall speed and the overall just entire feel of the UI. Also, let's get WireGuard on the same level as OpenVPN. Otherwise, I think it's got all the features you need, to be honest, and I really don't have a problem daily driving it. As for the hardware, again, they've made some serious strides in the last few years with way more options to choose from. Two things I'd like to see though are for them to start including the controller built into all the routers, and two, clean up the naming convention. It's hard to tell just from the model what it is that I'm looking at, which is kind of annoying both when I'm looking at it in my devices in the UI, but also when I'm browsing the store. This isn't super important, but it's kind of like the first impression, Everybody wants to make a good first impression. But that's all I have today. What do you think about Omada? Let me know down in the comments. If you like this video, then drop a like. And if you want to see Omada go head to head with Unify, then make sure you're subscribed so you can check that out when it goes live. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my well-priced SDN with all of the fancy network features. Y'all are great. And if you're still watching, you're a layer 2 switch. Thank you so much, and I'll see you in the next one.